Good morning, students. I would invite Deepashri ma'am to start the session. Yes, Deepashri ma'am. Deepashri ma'am, you can start the session.
Uh, good good morning. Am I audible?
Yes, ma'am, you're audible.
Okay.
You're audible.
So my screen is visible, right? Hopefully my screen
Yes.
is visible.
Yes, ma'am.
Just wait for 1 minute. Okay. So yesterday we started the thermodynamics and we did till the equations part. And I explained to you that in your exam, these formulas will come. They will just give you this function that anything instead of phi, they can be giving you heat like this. They can be giving you work done or anything along with the function. So once they give you the function, so now they will be asking you four equations and accordingly you just need to answer that whether this equation, this Euler's theorem will be going on. They are asking about this equation. If there is a plus sign, remember, if there is a plus sign in the options, then go for this. And if there is no plus sign, there is an is equal to sign between here, then use the Euler's theorem. So this what we have done in the last class till now. Till here, I guess no one has any doubt, right? Okay, so if here, does anyone has any doubt? Unmute yourself and answer.
No, ma'am.
Okay, so no one has no doubt, then prove that pressure is an intensive property. How can you do this? Pressure is an intensive property. So how can you do this? I will give you 2 minutes to answer. One hint is that P is equal to nRT by V. From this equation, you have to prove that pressure is an intensive quantity. How can you do this? Just remember those formulas. I told you that if the ratio between two extensive is this, ratio between two intensive is this. So how can you do this? Anyone wants to try? How can you do this? No one. See, this entire thing is what? This entire thing is an extensive property, right? This entire thing is an extensive property. Volume is also an extensive property. Yesterday I told you that the ratio between two extensive properties is always intensive. Ratio between two extensive property becomes intensive. Just study. This is something I have done for your revision. So, therefore, pressure becomes intensive. even if you don't know that something is an extensive property or an intensive property, try to remember the definitions. What is pressure? What is work done? So from that you can easily understand. Now, if you ask me, ma'am, how can you tell that NRT is an extensive property? Just go to this slide. Here I have given you the list yesterday to understand whether it is an extensive property or it is an intensive property. This. Okay, so go through this. Uh, go through this chart. Once this chart is clear and these equations are clear to you, like the ratio of two extensive property is intensive, product of one intensive, one extensive is extensive. Once you have memorized this property, then this entire chart will become easy for you. Okay, this is how you need to solve and do practice the regular class. That once the regular class is done, you can do it. Okay, so is the last question clear how to solve? Okay, so now we will be discussing about the process. So, process. So what is this? It is the path followed when the system changes. Now we are talking about the path. Path followed when the states of the system changes. When system changes its state. So yesterday I told you what is the change in state of a system. So when any of the property of a system, of any kind of system is changed, then we say that the state of the system is also changed. So process can be of two different types. Okay. So process can be of two different types. So one is the physical process and another is the chemical process. What is the physical and the chemical process? Anyone wants to answer? What is the physical and the chemical process? Okay. So physical process are the process during which chemical identity of the system remains unchanged. So here chemical property of the system remains unchanged. Chemical property of system remains unchanged. Okay, so this is what a physical property is. Now we will be discussing what is the chemical property. So I told you chemical properties of the system remains unchanged. So what are these chemical properties or what is the chemical process? So during the chemical process, one type of the substance get converted into chemically another type of the substrate. Okay, so here one type of the substrate gets converted into chemically other type of the substrate. Chemically different type of the substrate. Okay. So in your younger classes, when you were quite young, so maybe at that time you will know about the physical process and the chemical process. Like we used to say that cutting of the tree is a physical process. Why? Because it regains itself back. Cutting off your hair is a physical process, right? So these are the so if this phase remains same. So one thing, remember that whether it is a physical process or chemical process, if it is reversible in nature, it is physical process. If it is non-reversible in nature, then it is a chemical process, like cooking anything. So it can't be gained back to the original raw form. So it is a chemical process. But cutting off a tree is a physical process. Why? Because the tree will once again develop into a new plant. So that is the reason it is a physical process. Okay. So this is the basic definition for physical and the chemical process. So now we will be discussing about, wait. Just wait for once. Yeah, so everything is visible. I guess everything is visible now. So now we will be learning in details about the physical process. So what I told you about the physical process, what is the definition of the physical process? Process during which chemical identity of the system remains unchanged, like melting, cutting of the trees. Okay, so melting, vaporization, these are all the physical process. These physical process are not greatly reversible in nature. Reversible means what? That once the water is melted, then it can be again cool down to become the to make it ice again. So okay, it is a physical process. So what are the different types of the physical process? One is the isobaric process. Okay, one is the isobaric process. Second is the isochoric process. I will be telling you what are these. Third is the isothermal process. Okay. Fourth is the adiabatic process. Fifth is the cyclic process. And sixth is the polytropic process. Polytropic process. What is the isobaric process? You know what is the constant in the isobaric process? N and P. Pressure and moles. These two are constant here. Okay. So isochoric process is N and volume. They remain constant here. Okay. Isothermal process is moles and temperature remaining constant here. Okay. Adiabatic process means N is constant. But what is Q? Yesterday I told you. What is Q? Anyone? What is Q? No one. Is anyone even studying? What is Q? I told you yesterday in the yesterday's class. What is Q? Unmute yourself and answer. What is Q? What is this Q? I told you in the last class. Am I not audible? I guess I am. So what is Q? So Q is actually what? Q is the heat. These simple things you can't answer. Is there any problem that you can't understand? Okay. And here delta H will be equal to delta U will be equal to delta G. And there is another type of process which is the polytropic process. Okay, remember one thing, during the isochoric process or the isobaric process, the pressure remains constant throughout the system. Okay, so what is the in the isobaric process, the pressure remains constant throughout the system. In isochoric process, volume remains constant. Isothermal process, temperature remains constant. Okay, so these are the different types of the physical process. In your exam, in your boards, they can just ask you about the name of the process and the constant terms. Okay, so this is something very important for your boards. Now answer me a question. If the initial and the final temperature is same, so then the process must be isothermal. True or false? Hmm? I told, yeah, say. I told you that one question. If the initial and the final temperature of a system, of any system, is same, then the process should be
Isothermal.
process is isothermal. It is true or false?
True.
True. No, it is not true. It is false. But can you explain me why I have said it is false?
Ma'am, it will be constant. No.
Yes. So what is the difference between constant and same? Constant means that the temperature is, I told you that, remember one thing, for any kind of process, if it is an isobaric process, pressure remains constant throughout the system, like throughout the process. Okay. Same for this. They had temperature, here volume, here temperature. So they remain constant throughout the process. And I told you what here, that suppose this is a system, okay, and T1 of the system is, T1 is the initial temperature, 21 degrees Celsius. And T final of the system is also 21 degrees Celsius. Okay, now there is T2, T3, T4, T5, T6. Okay, between initial temperature and final temperature, suppose there are this many temperatures, but these are not 21 degrees Celsius. They are not 21 degrees Celsius. Suppose this is 18 degrees Celsius, this is 20 degrees Celsius, this is 22 degrees Celsius, this is 24 degrees Celsius, and this is suppose 19 degree Celsius. Okay, and finally again the temperature is 21 degrees Celsius. No. So the initial and the final temperature remains same. But in between the temperature is varying. If the process is isothermal, then T1, T final. Here T2, T3, T4, T5 and T6 all will be 21 degrees Celsius. Okay, the temperature will not rise and fall. So the temperature will be same throughout. That is the difference between the term constant and the term same. Is this part clear? They can ask you this type of the tricky questions. Okay, is this part clear to everyone?
Yes, ma'am.
Okay, good. Okay, now starting with the chemical process. What I told you, that something that is irreversible in nature, like cooking. Okay, so once you have cooked, suppose you have cooked vegetables. Can you get the vegetable again in the raw form? No. So obviously it is a chemical process. So what is the chemical process? Chemical process. Now wait. Okay, so I told you during this process, one type of the substance get chemically converted into another type of substance. So during the chemical reaction, temperature is always kept constant. So here, remember, temperature is always kept constant. So wait, let me write you all the properties here. So first, what we have told, that in chemical process, one type of the substrate is chemically converted to another type. Converted to another type of the substrate. Okay. So next is what? So during the chemical process, the temperature is always kept constant. Temperature is always constant. Okay, this is the second property. And out of the pressure and volume, one parameter will be constant. So between pressure and volume, either of them means what? Only one of them will be kept constant. Okay, so these are the three different major properties for the chemical process. Okay, suppose A is converted to B. Okay, here there is a pressure and temperature is constant and volume is different. And when B is converted, we are getting 200 kilojoules of energy as an outcome. Okay, and also A in another process, suppose it's not A. Okay, it is, let's consider, so that you don't get confused, let's consider it to be X. X is converted to Y. But here, who is kept constant? Volume and temperature. I told you either pressure or volume will be constant. Okay. So here volume is variable. Okay. Here volume is variable and here pressure is variable. Is this part clear so far? And these are kept constant. These are the constants. Okay. So these are the constant, and along with this, when 100 kilojoules of energy is released. Okay. So what I can say or what I can conclude is that QP, what is the heat loss of the system, is delta H is equals to minus 200 kilojoule. Remember, if it is on the right hand side, always write like this. Okay, and here we will be writing whatever is constant, we will be writing QP. Okay, and here we will be writing QV. Okay, or delta U. This is minus 100 kilojoules. So if anything is written on the right hand side of any kind of the chemical reaction, if it is always written on the right hand side, always give the negative sign. Okay, see here it is written on the right hand side, so that is why I have given the negative sign. This is a clear indication. So again it is written in the right hand side, so again I have given the negative sign. Okay, so this is a basic form of the understanding. Okay, so once this is done, so one thing you need to know that although phase transformations are physical process, still we will apply all laws for phase transformation which we use for chemical reaction. Okay, so now this is a general note. You have to remember this every time. That note, I just told you that vaporization, melting, these are all physical process. So although, remember this, although all phase transformations are what process? Physical processes are physical process, but still we will apply all laws for phase transformation which we use for chemical reactions. Okay, always remember this. This is very important. This is a law. So now when I will be showing you that if water from ice is converted to liquid and we write this, so if someone writes, so in your exam, if it is written here, water solid converted to water in liquid form. Here pressure and temperature is constant and delta fusion of H is positive. Okay, now they ask you if this equation is right or wrong. Okay, in your exam. So if they ask you something like this, okay, so what you can do is that you can think that, okay, ma'am told us that all the physical transformations like vaporization, melting, these are physical process. But now ma'am has used here the chemical reaction, the equation for a chemical process. So this should be wrong. No. Remember this note that although those phase transformations are physical, but for writing the equation, we use the reactions for chemical equation. So this is 100% true. Okay, so this is 100% true. Don't write it false. But if in your question they ask you water to ice, water in solid state is converted to water in liquid state, and they ask you if it is a physical process or chemical process, then you have to answer that yes, it is a physical process. But while writing the equation, okay, so while writing the equation, we use the format for chemical process. Is this part clear to everyone?
Yes,
The
ma'am.
yeah, so the exceptions and the okay, wait. Yeah. Okay. So any process can be carried out in two ways. Okay. Now this is another heading. Any process can be carried out in two ways. What are these two ways? These are reversibly and irreversibly. Reversibly and second is irreversibly. Okay. So any process you can carry out in two ways. So what is the reversibility and irreversibility? So here I am writing the reversibility and here I am writing the irreversibility. Okay. So what is this? Let's draw. I will be writing the conclusions in the next page. Okay. So this is a container filled with gas, and here I have written that on the gas these structures are present. Okay, so here in the reversible process, external forces changes gradually. Okay, but here in the irreversible process, external force will change suddenly. Okay, so this process will, reversible process is slow and hypothetical. This process is really fast. So, okay, these are the different conclusions they have done. External pressure, this is suppose an external pressure. This external pressure changes at every instant, okay? And here the process will take at a constant pressure. See, I have put weights here. So these are the different weights here. So this will change the process at a constant pressure. So if the process is reversed here, if the process is reversed, it will follow the same path, but for this, it is not applicable. Here, they will follow the PV is equal to nRT. Here, we can apply PV is equal to nRT only at the final and the initial points. So, I've drawn a lot of the conclusions, right? So, let's just write the conclusion. Remember this picture. Okay, so for first, I am writing for the reversible process. Whatever I am writing for the reversible process, the opposite thing will be in the irreversible process. Here, what happens? External force changes gradually. External forces change gradually. Okay. So this is for our reversible process. Second cause is this process will be slow. Process will be slow. But this is something hypothetical. Means this has not yet been proven. This is slow or fast. It is still under research. Okay. External pressure, like the external pressure, changes at every instant. Changes at every instant. So here we can write an equation like pressure on gas is equal to pressure on the external plus small change in pressure. Okay, so this may tend to 0. Okay, so this variable may tend to 0. So external pressure will be changing at every instant. And P of gas is equivalent to P of external. If this whole quantity, I said that they may tend to 0. So if this whole quantity becomes 0, so obviously pressure of the gas and external pressure remains constant, right? So this is what they are saying, that since this term is almost 0, so whatever external pressure we are applying, the same pressure is felt by the gas inside the container. So pressure of the gas, pressure on gas is equivalent to pressure given by the external. So what is the graph here? Plot of P of gas versus volume. This graph is important. Here it is volume, here it is P of gas. Okay, so the graph will look like this. Okay, so the graph will be look like this. So this is our initial point A and this is our final point B. Okay, so these are the things for the reversible process. Now, if the process is reversed, very important, if this process is reversed, it will follow the same path. Same path. For example, water in solid form to water in liquid form. Have you ever, here we have applied some heat. Okay, here heat is given, here no heat is given. Okay, so if you heat the ice, then it will become water. And again, if you remove the heat, that means if you cool down, then it will become solid. So this is a reversible process, right? So it is following the same path. The path they are using to reach the final destination, the same path they will be using to reach the original form. Okay, if they are allowed to. Okay, so here we apply PV is equal to nRT. PV is equal to nRT. Now you must be wondering why ma'am is asking these formulas, because in later chapters, in class 12th, I guess, you will be learning about solutions and everything. So there, if you know that the process is reversible or not, then you can easily apply PV is equal to nRT. In your class 12th, I won't explaining why I have applied PV is equal to nRT or why I am not applying using the formula PV is equal to nRT. So there you can easily understand, okay. So since in class 11th, ma'am told that we can apply PV is equal to nRT for a reversible process. So that is the reason ma'am is solving that particular numerical using PV is equal to nRT. Okay. And in reversible cyclic process system as well as the surrounding are restored to their original position. This is another important point, that cyclic process, if the case is reversible, this is happening only if the case is reversible, that the cyclic process system as well as surroundings are restored to their original position. Okay, so these are the things you have to remember for the reversible process. These are all the properties of the reversible process, and you know what equation to apply, how the pressure is varying, and so on. So these are all the general properties. Okay, so now we will be discussing about the irreversible process. Okay, so now let's discuss about the irreversible process. So what is an irreversible process? Here external pressure. Here the external pressure changes suddenly. There it was changing on a regular basis, but here it will change suddenly. Okay, this will change suddenly. Then this process will be fast. But this has been proven. It is not a hypothetical condition. Third, this process takes place at a constant pressure. Takes place at a constant pressure. Okay, takes place at a constant pressure. So P of gas will be equal to P of the external plus minus delta P. So in the last case, we were considering this part to be 0. In the last case for reversible, we considered this to be 0, right? Here for P irreversible, this is not equivalent to 0. Most of the times, this is not equivalent to 0. This has a definite value. Okay, so P of gas, obviously P of gas is never equivalent to P of the external. Okay, now we cannot plot here. One of the important, we cannot, okay, cannot plot P of the gas versus volume curve. So if in your exam they give P of gas and volume here, this is the initial point A, this is the final point B, and you draw like this. Okay, so this is an absolute wrong statement. Okay, this is absolutely wrong. So what is the graph? There is no graph. Okay, so always remember P of the gas versus volume. There should be no graph. No graph is there. This is the original form. Okay, so if they give you this, either this is the curve of the reversible process or there is no curve for the irreversible process. Okay, now if the process is reversed, here I'm writing, if the process is reversed, if the process is reversed, then it will follow a different path. Follow a different path. Okay, so first of all, irreversible process can't be reversed. Okay, suppose you have cooked meat, a piece of meat you have cooked. Now you want the raw meat. So for cooking the meat, you have, here I am giving the example. For cooking the meat, you have given spices. Okay, you have given heat. Okay, so it is a cooked meat. But when the meat is not, like, if you want this back, raw meat, if you want the raw meat back, then what happens? You just remove the spices and you cool it down. minus of heat. Will you get the raw meat? No, it is not possible to get the raw meat, right? It is not possible. This whole phenomena is not possible. It does not exist. It does not exist. Right. So this is the fact. If you want cooked meat to raw meat, if you are a scientist, you become a scientist and you want this from cooked meat, you want raw meat again, then you have to discover a whole new phenomena. Okay, so first of all, irreversible process can't be reversed. But if, I said here if, so if you somehow try to reverse an irreversible process, then it will follow a complete different path. Okay, so it will be following a complete different path. Is this part clear to everyone? The in-depth difference between the reversible and the irreversible process. And one more thing, for irreversible process, cyclic process is restored to its original position, but in the reversible, but surrounding is not restored to its original position. Okay, so for the reversible case, if it was reversible, both cyclic and the surrounding, they would have been restored. Okay, so for them both would have been restored to original position. But since this is an irreversible process, so only the cyclic process will be restored, but not the surrounding. Okay, so this is one of the important thing you have to remember. So is the concept of the process, this is your whole process. Whatever question you will be getting from process will be from this part. Is the whole concept for the process clear to you? So then we will be starting about the heat capacity. Okay, so let's start about heat capacity. Ready? Okay, so let's start about the heat capacity. What is heat capacity? So heat capacity is represented as C. So the amount of heat which is required to raise the temperature of m of any substance by 1 degree Celsius. So this is the standard definition. So the amount of heat, okay, this is the book definition, amount of heat which is required to raise the temperature of m of substance, by 1 degree Celsius. Okay, so this is the heat capacity. So C is equivalent to Q by del T. This is the formula for heat. And unit is in joule per Kelvin. Okay, so here C is represented as the heat capacity. Q is the heat exchanged. Always don't write Q as heat. Q write as heat exchanged. And del T, if only T is given, write temperature. If del T is written, write temperature change. Okay, temperature change in Kelvin. Okay, so you have to convert it in Kelvin. So heat capacity, I told you yesterday also, it is an extensive property. Okay, so this is the thing. What is heat capacity? But from the definition you can get, suppose this is a beaker full of water. Okay, now you have heated it. So you have heated it. Okay, so you have heated this, and suppose initially it was 20 degrees Celsius. After heating, it has become 21 degrees Celsius. So to convert this process, to do this process, some amount of heat has been exchanged and there is a change of temperature of 1 degree Celsius. So this entire phenomena, so whatever you are, when you use this formula and give this value, whatever you are getting, that is the heat capacity of this substance. Okay, so this is the plain definition for the heat capacity. So C, okay, one thing, C is also a path function. Okay, remember this. C is also a path function. Now, we will be learning about molar heat capacity. We learned about heat capacity. Now we will be learning about molar heat capacity. What is this molar heat capacity? So molar heat capacity is amount of heat required to raise the temperature of 1 gram of substance. 1 gram of substance by 1 degree Celsius. Heat capacity was m gram of substance. Okay. Remember, if it was heat capacity, it was the amount of heat required to raise the temperature of m gram of substance. M gram means anything. M gram of substance by 1 degree. But here you need the amount of heat to raise the temperature of 1 gram. Okay, 1 gram specifically. So that was m gram and here it is 1 gram. So this is the basic difference between molar heat capacity and the heat capacity. Okay, so that is the molar heat capacity. So here the formula is C by M. M is the gram, which is the molar heat capacity. Molar heat capacity is Cs. Okay, molar heat capacity is Cs, that is Q by M del T. Okay, so again it is joule per Kelvin. Okay, and it is an intensive property. It is an intensive property, but it is a path function. Remember, the heat capacity was what? Heat capacity was an extensive property. Molar heat capacity is an intensive property. Okay, I am highlighting so that when you read, you like see, you notice this difference. If it is a molar heat capacity is intensive property, but the heat capacity is an extensive property. Okay, I am writing it, I am highlighting it so that when you read, you don't miss these points. Okay. Okay. So now another thing, in case for the gases, heat capacities are of two types. Okay, so next, I'm writing in the next slide. In case only for gases, in case for gases, okay, heat capacities are of two types. Okay, so what are the two types of the heat capacities? Molar heat capacity, molar heat capacity at constant pressure, and another is what? Molar heat capacity at constant volume. Okay, so we represent this as C P M and we represent this as C V M. Okay, so these are the two types of the heat capacities for kind of the gases. So it is an intensive property and also a state function. Always remember, CPM is greater than CVM. This is, you have to remember. Okay, so It is an intensive property and also a state function. So that's all and state function. Remember, those were the path function. Here it is state function. So what is the difference here? This. So those were the path functions. Previously, it was path functions. But here, this is a state function. Okay. So this is the standard thing we have to notice. Okay, now, so is this part clear? Then I will be doing for the ideal gas. After doing the ideal gas, we can end the class. So just for the ideal gas, so let's hear what is for an ideal gas. For ideal gas, this is not applicable for any other gases. Only for ideal gases, we write Cp for an ideal. Okay, this derivation comes. Okay, Cp minus Cv is equals to Nr. Okay, and if we divide both sides by N, minus Cv by N is equals to Nr by N is equal to R. Okay, so Cpm minus Cvm is equal to R. Okay, now you can ask me why. This entire thing is equivalent to this. This entire thing is equivalent to this. See in the slide, in the last slide. Okay, this entire thing, this can be represented as like this. See, something by M. Okay, so C by M. So C by M is the CS, and I told you this can be of two types, which is the CPM and the CVM. So here I am writing, I have written CPM in the place of this expression. Is this part clear? Why I have written this expression here? How I have written this expression here? So from this, I have got this. Okay, now remember one thing. CPM, this is an important derivation, divided by CVM is equal to gamma. So this is an adiabatic coefficient. Okay, so this is an important derivation for an ideal gas. If they ask you prove eta by eta is equal to eta, then just do this. You can do another step that eta is equal to eta, R is a constant, so anything by becoming this becomes also constant. So R, so from here you can actually do like CPM divided by CVM minus CVM divided by CVM is equals to R by CVM. This is CPM divided by CVM minus 1 is equals to R by CVM. So CPM divided by CVM is equals to R by CVM plus 1. This entire thing is a constant. Okay, this constant we have written like this. Okay, so is this part clear? I have not written this step because from this step directly do this. Don't do this. Okay, so this is not acceptable. So for your understanding, I have shown you this. So is this part clear? Whatever I have done. So don't do this in your exam. So if they ask you, directly do this process. Okay. I hope everything is clear to you. Anything you want to ask me? So anything you want to ask me? Any doubts? Anything? So from the next class, we will be starting with the degree of freedom. Okay. So we will be dealing with the degree of freedom from the next class. Is this part clear, everyone? Okay. So from this, you can do one more thing from here. CPM by CVM minus of 1 is equals to R by CVM. Something I have showed you just now. Okay. Now, you know CPM by CVM is gamma. Okay. So, this is an adiabatic question. Okay, so we consider CPM by CVM like this. Now, from this, what we can write like this? So, gamma minus R, 1, is equal to R by CVM. Okay, so CVM is what? CVM is equal to R by gamma minus 1, and CPM is what? It is equal to gamma R by gamma minus 1. So these are the two formulas you have to remember. Okay, one more thing I want to say before ending today's class. So after this, I am writing here. So for solids and liquids, this is something we have done for ideal gases. But for solids and liquids, CPM is equivalent to CVM. Okay. And it is equivalent to CM. So there, for solids and gases, this equation is not applicable. For solids and gases, no. Okay, this is strictly for ideal gases, only for gases this equation is applicable. Okay, so for solids and gases, this is something. And for an ideal gas, one more point, for ideal gas, we can write like, if C is given as a function of T, this is something for IIT students. C will be equivalent to A plus BT plus CT square and so on. Okay. They can ask you C, they will give you what is this function. And if the values are given, just write like this and solve the quadratic equation. Is this part clear? Or sometimes in your Neet, they can ask you like this. Let's suppose heat capacity is a function of temperature. So is this statement correct or not? So then write this. And for solids and liquids, remember this. So is this part clear to everyone, whatever I have taught so far? From the next class, we will be doing with the degree of freedom. One more thing, nobody asked me, ma'am, what can be happening for different kinds of the processes, like heat capacities. Remember this, heat capacities for various process. This, whatever the formulas I am going to give you now, this is strictly for the IIT students. They can get, they may not get. In the Neet, I have never seen questions from heat capacity for various process, but the equations part I have seen. So for isobaric process, first let's consider for isobaric process. Okay, so for isobaric process, what will be happening? Cp is equal to Qp divided by delta. For isochoric process, Cv, because volume remains constant, Qv by del T. Okay, that will be equivalent to 0. For adiabatic process, C is equal to del Q by del T. Actually, not for this. For this, they won't be 0. Only for the adiabatic process, it will be 0. Okay. So one more question they can ask, like they can give you this equation and they can just ask you. for adiabatic process, and one more process is the isothermal process. Yeah, isothermal. So for isothermal process, what will you get? C is equal to del Q by del T. It will be infinite. Okay. So these are the different equations that you can expect for heat capacities for different kinds of the process. So next class we will be starting with the degrees of freedom. Tomorrow, I know tomorrow is Sunday, but tomorrow I will be taking a class, and tomorrow it will be a long class compared to today's class because tomorrow is Sunday, and after this class you won't be joining another class. So tomorrow a long class I will be taking. Okay, so is this part clear to everyone? Whatever I have taught so far, do read and come back in the next class. Next class we will be doing with the isothermal, or we will be doing with the degrees of the freedom, and then we will be starting with the isothermal processes and so on. Okay? Is this part clear?
Yes, ma'am.
Okay. Okay then.
Yes, ma'am. Thank you, ma'am. Students, you can join the next session. Join the next session.